Hello and welcome to Risk Analytics. We are going deeper into simulation, and this is the first example problem. And we'll walk over a basic problem on profit loss, and then we'll see how we can use simulation to analyze our profit and loss. My name is Hari Rajagopalan, and I'll be walking you through this lecture. So let's take a very simple example. We have a company that sells a product for $10 per unit. So one product selling price is $10 per unit. Cost is $5 per unit, and if you don't sell the item, you can sell it for scrap at $1 per unit. So we have selling price, cost price, and salvage price. The store on average sells 5,000 units with a standard deviation of 1,000 units. So this is your demand. So on average is 5,000. There's a standard deviation of 1,000 units. So now we are asked to do a whole bunch of things. The first one is to build a deterministic model where the store produces 8,000 units and the demand ends up being 5,000 units. So remember, what the store needs to produce is usually a decision variable, and this demand here is not in the store's control. And right now that's your probabilistic or stochastic variable. So first step is to assume certain numbers and build the model. Then we are going to modify that deterministic model so that we can use this normal distribution of 5,000 and 1,000. And that's because they're given mean and standard deviation. Then it needs to be a normal distribution. And you're going to run a simulation for 1,000 runs and generate statistics. You're also going to answer what's the probability the store is going to make more than $15,000 using this. Once we finish this, we're going to build a data table where how much you produce. Right now we said 8,000, but we're going to do a what if analysis within the simulation. So we're going to assume that store produces 4,000. What happens to the profit and the probability? If you do 5,000, what happens? If you produce 6,000, 7,000, 8,000. So we're looking at 1, 2, 3, 4, 5 different simulations, and you're trying to find the statistics and the target probability. Once we've done this and we've analyzed the data table, we're going to run an optimizer. So now we're going to look at production between 4,000 and 8,000, and we're going to optimize for maximizing our average profit. Okay, so multiple things we're going to do. Please follow this very carefully. You should be able to replicate this Excel step by step. And if you can do this, you are in good shape to do your simulations for other problems. So let's start with the deterministic model. So the deterministic model, we are looking at, first we look at the inputs. And so inputs we have is selling price is given, cost price is given, salvage price is given. These are given to you, and your demand is an estimate. So stochastic variable is an estimate with a mean and standard deviation. So for the deterministic model, we are going to assume this is 5,000, right? The decision variable is how much you need to produce. You're also going to then calculate how much your sales are going to be, how much your salvage is going to be, how many units you're going to sell, how many units you're going to salvage. And then once you do that, you can then calculate your sales revenue, your salvage revenue, the total cost. And so your total profit will then be calculated from these three variables, right? So this is your building your model. So let's look at, for example, this, we're going to put 5,000 units for demand. Production, we have first, you said it's 8,000, so we're going to enter 8,000 here. So let's look at the sales. How much you sell depends upon your demand and your production. If production is greater than demand, right? If production is greater, if you produce more than the demand is, then you're going to sell whatever the demand is because you have enough units. If production is less than demand, even if you have more, even if the demand is more, you don't have that many units, and so you're going to only sell production. Now, you cannot use an if function. You cannot say equal to if production greater than demand, then put demand, right? If production else, put production. You can't do that because, as we talked about earlier, in prescriptive analytics, if function causes a lot of problems and you want to avoid using if function as much as possible. But what we know is that the smaller of the two units is your sales, right? So whether it's demand or production, whichever is smaller, that becomes your sales. So you can use equal to min production comma demand. Similarly, salvage needs to be calculated. Now salvage is only if happens when production is more than demand. When production is less than demand, salvage is 0. If production is more than demand, then production minus demand gives you salvage. So whenever production minus demand is a positive value, right? Production minus demand is a positive value, that becomes salvage. If it's a negative value, there is no salvage and salvage is 0. Again, you want to avoid using the if function in Excel. And so we are going to use equal to max, you put 0, and then production minus demand. So if this is positive, you take the bigger number. If it's negative, you take 0. Avoid if functions. And now you can calculate, it's pretty easy to calculate your sales revenue. That's selling price, $10 multiplied by sales. Salvage revenue is salvage price, which is $1 multiplied by salvage unit. Total cost is cost price multiplied by production. And so your total profit is set up here. And that essentially gives you your Excel file. So let's go to Excel and we can look at this deterministic model. And the next step is then to take this deterministic model and then convert it into a probabilistic or stochastic model. And the things we need to focus on here is what is your stochastic variable. In this model we have only one. There could be more than one, but in this model there's only one. And then what is your dependent variable or output cell, which is your total profit. Okay, so we're going to stop here and we're going to move on to Excel. So here we have the basic model. You type in your inputs, put your values in. This is your stochastic variable. Write down demand. In the deterministic model, we are assumed to be 5,000, right? Production, we are essentially at this point of time, we are told that it's 8,000. We'll leave it there. And then we've got to have the calculated variables. So calculated variables, remember, we shouldn't use an if function, but we can use a minimum of demand and production, right? And so that comes here. Your salvage is essentially production minus demand if it's positive. So this would be a max of 0 if production minus demand is negative, or it's production minus demand, right? Your sales revenue is going to be your selling price multiplied by your sales. Your salvage revenue is going to be salvage price multiplied by your salvage units. Cost of production is going to be cost price multiplied by production, right? And then your forecast, this total profit will be sales revenue plus salvage revenue minus cost of production. And this pretty much you have finished this, okay? So I'm going to delete this and we're going to go here. This is where I have put all the values in and the formulas are in here, and you have set up your model. So you got your model, deterministic model, all set up, and it's ready now to be converted into a stochastic model. So we have our deterministic model. Let's go back here. So here is our deterministic model, right? All that is set. And now we are going to convert this into a stochastic model. So here, assuming this average 5,000 unit, place close attention to this. That goes away, and you are going to replace it with a probabilistic function. So this is average of 5,000, standard deviation of 1,000, which means it's a normal distribution. So whenever you get average and standard deviation in your exams or your questions, that's a normal distribution. So PSI normal 5,000. So you're going to put that here wherever you put 5,000. Also here, you're going to add PSI output. All right, so let's go to Excel. I'm not going to do this specifically, but I'm just going to show you where it's done in Excel. So we were in the deterministic. I'm just going to the stochastic part where we are changing stochastic variable right here and then the profit. So you go here, you see this is, I'll come to that, but we're going to put PSI normal 5,000 and 1,000. And since here I want the integer values because I'm looking at units, I'm actually putting int here. So let me go back a bit. I'm up again here. I'm going to put PSI normal, right? You can use the fx function here and it'll say mean and standard deviation if you want the pop-up menu, but you can put 5,000 and 1,000 here. And it also tells you what it is. It tells you what these values are, and you can use that, and then you can plug it with an int. Notice this at here. You don't have to put this at. That was for an earlier version of risk solver. The new version doesn't require you to put that at. But you will see this in a lot of my videos. Also, when you come here, let me not run the simulation. You need to add PSI output. Again, you don't have to put this at function, right? And you just have to put PSI output. All right. So once you do that, you will notice. Now remember, I've got other. But you will notice under simulation, under stochastic variable, C8 will come here, and under uncertain functions, C20 will be right here. So C8 and C20 should appear here under uncertain variables and uncertain functions. All right. So that's essentially the Excel component of your simulation. Now, let's go back to PowerPoint where I show you step by step how to run the simulation. We are going to use the options menu, and then we are going to use this button, but I'm going to show it to you in PowerPoint before we come to Excel. So now we have set up the problem, and let's see if we can run the simulation. So to run the simulation, you are going to go to options right here. So under Analytics Solver, options, click on options, and you're going to see this particular window. Now, when you see this window, all you have to do, remember you're running 1,000 trials. This is the trials per simulation, and you're going to change that to 1,000, right? And then in this particular case, simulations to run is 1. So you're only going to have 1 simulation, okay? And then you see it, uncertain variables and stochastic variables, and that's your demand and your output, which is your total profit. And you're going to click that to run the simulation. So let's go back to Excel and let's run the simulation and look at some of the results there. Okay, so we have options here. I'm going to say 1,000, going into 1,000, and number of simulations is 1. Don't worry about the rest. Just use default values, and you can try and run them multiple ways. One is using this button, and it'll run the problem, or you can just double click wherever there is output, PSI output. Now before we do that, I want to show you, whenever you have a PSI function, you can double click that cell and it will show you what the distribution is. In this case, this is a PSI normal, and you can see what the normal distribution is like, and it'll tell you there's a 90% chance you're going to be between 3,355 to 6,455. There you can get the values, mean and standard deviation. You can get the different percentiles for it right here. And so a lot of information can come. Similarly, when we run this, let's go ahead and run this model. And you can see you get a bunch of information here. So your total profit average for a sample of 1,000 runs is about 12,990. Standard deviation is about 9,000. Remember, this is sample standard deviation, right? And you can get your variance, skewness, kurtosis, your mode, minimum. You mean in the 1,000, the minimum value, you make a loss of about 19,000. Maximum is about 40,000. So that's the range. You have the mean absolute deviation here. You can get the mean 95% confidence interval of the standard deviation, so you can kind of have an estimate of what your actual standard deviation is, population standard deviation is. Here's your standard error. You can get the values, percentile values here. So a lot of information. And a lot of this information and you could go through this. There is a Six Sigma option for those of you who have done production and operations control. This is the process performance in Six Sigma. And then you can kind of look at what kind of charts you want, etc. But what I want to do is to and of course, there is sensitivity to which cell. So obviously, this solution is sensitive to C8 a lot. What I want to do is to essentially take a look at this and bring all the statistical data down here. Okay? And that's what we're going to work on in the next. Go back to PowerPoint and come back to Excel. And how do you bring all these statistics over here? So now we have created the stochastic model. We have put the output, PSI output, and we are going to calculate the statistics based on this. So right now at this point, when we say demand is 5126, this is just one sample point. I want you to understand this very carefully. This is just one instant out of 1,000 different values of demand that this total profit is calculated. So your profit is not 14,134. You don't know what your profit is because you don't know what this value is. So you want to figure out on these different 1,000 values, you're going to have 1,000 different profit values because that's your simulation is 1,000. So you're going to have 1,000 sample points, right? And so you need to calculate your average profit, your standard deviation, percentiles, confidence level, and then look at the probability of making more than some targeted value, right? And now we're going to Excel to figure out how to do that. Okay, so I wanted to show you this. We have set up the entire model. We have the stochastic variable. Now in your other models, there may be more than one stochastic variable. You have the PSI output all set and ready to be forecasted, and then you want to generate a lot of these statistics here. It is important to note that when you open up a file and you have these statistics, you will see this NA and value not available error, right? Don't freak out. Even when you get a proper, you've set it up and you've done it, you close and open the file, you will probably get this at the very first one. All you have to do is to run the simulation again. So you either press this green button or double click right here, run this, and you will get your answer. Okay, and I'll show you how to freeze this. Towards the end, I'll show you how to freeze this entire workbook once you've finished the entire workbook. But the freezing does not happen if you just do it for one worksheet. It'll happen for the whole workbook. So now that you run it, you actually got the data for it, right? So how do we get this data? So you have, this is the forecasted variable. This is what you're looking at. And it's important to understand this is just one sample. This 21,307 is just one sample where demand was 5,923. Remember, you're sampling about 1,000 times, your 1,000 trials, with from something with an average of 5,000 and standard deviation of 1,000. So you're getting a lot of numbers here, and each one of those numbers plug into this, and therefore you have a sample with 1,000 total sample sizes, 1,000 total profit, right? So you can now calculate the average profit and then the standard deviation. So how do you do the average profit? So I'm going to show you multiple ways to do this, and I'm going to show you the way I use the most. So one way is to go to these results, go to statistic, go to mean, and then it says, please select the cell where the statistic will be placed. And so let's assume I want it right here, right? And you need to then change, it needs to be C20, okay? So that's one way of doing it, right? Another way, which I usually do, is to say PSI mean, since I know what this is. And then I go here and it's asking for the cell name. And I click that and I click OK. Now, I'll come to the simulation number. We won't do it right now, but when you do data tables, you have to use the simulation number. We'll talk about that. But right now, you just do that, right? And you'll see that it says NA. And so if you run it, that will give you the value, all right? So you don't have to run it every time, just kind of, so it's PSI mean, and the cell name is the cell which you have the PSI output. Similarly, standard deviation is PSI STD dev C20. Again, it's the same cell. So you can go here, look for the statistic, and look for standard deviation right here, right? Standard error is PSI STD ERR, and that gives you the standard error. Now, I'm going to ask you the same set of statistics, so you might as well just open up this and keep this so you know what the functions are. For confidence interval, whether you want 95 or 99%, it's PSI mean CI, and you're asked for two things, cell name and then confidence level, which you'll enter 0.95 or 0.99. And this is your sampling error. Notice that, again, from a value, this becomes NA again. You don't have to stress out about it. You just have to run the simulation again. Okay, so this is your confidence interval, and since this is in dollars, I'm just going to go back and make this currency so we get that. Notice that the total profit keeps changing, and now we actually are showing a loss right now if your demand is 3,303, right? So it keeps changing every time you run it, right? So once you get the confidence level, you can then calculate. Here we go. We are calculating your average profit plus this sampling error, and then here again this minus the sampling error. So you can do it this way, and I'm in an old risk solver they didn't have that, so at that point of time I used the norm.s.inv like we did in the descriptive analytics, and I've actually calculated it here. So that takes care of confidence intervals. Let's come to percentiles. To do percentiles, you're going to use equal to PSI percentile, right? And your cell name is, of course, the cell which has the output function, and then the percentile value. And what I often do is I use the $sign for the cell name, and then I put all the percentiles I need, and I can just copy this down, right? So this tells me your 10th percentile profit is about 1,473. And so you have a 10% chance, you have a 90% chance of making a profit more than 1,473, and so on, right? So the percentiles give you a nice little figure. 50th percentile is your median. So your average is about 12,991. Your median is about 12,986, pretty close, right? And then you can take your 90th percentile. In this particular case, in this run, it came out to be 24,506.5. Now, this value here is based on the sample, right? This is a 90th percentile for the sample. So if you want to build a 95% confidence interval for this 90th percentile, and in one of my earlier runs, it was 24,517, but now it's 24,506. It's going to change every run, so you can't have it static. Then I need to use this formula here. So I'm going to use the 90th percentile, which is 0.9, plus the z-score, right? This is the z-score, plus the square root of that 90th percentile multiplied by 1 minus 0.9 divided by your sample size. So this will give you the upper confidence level. The lower confidence level has the same formula with 0.025, 2.5%. And so I know that this value of the 90th percentile is actually in the population. I'm 95% confident it is between 91.86% and 88.14%. So you can see that this value is changed here, and that's okay. And finally, we have a target. So let's assume that we want to know what's the probability you're going to make it 15,000 or more, a profit of 15,000 or more. And so the PSI target is the function you're going to use. Your cell name, of course, is going to be your cell which has the PSI output. Target value is going to be this 15,000. And so here it says, hey, you have a 58.8% chance of getting less than 15,000. So for you to get more than 15,000, you got to do 1 minus that value, right? And of course, once you do that, it disappears. You can rerun it. That's okay. So let's look at what's the probability we're going to make a profit, right? So we need more than 0. And we have a 92% chance you're going to make a profit. And that's, you can also see that here. You can kind of move this here. You can see where this value is and say, hey, I want to set it to, and kind of see what the percentages are here. But this is where we want to set it up. Once you have your, once you finish your simulation, all right, once you finish your simulation, your data table optimizer, you can go to Analytics Solver and click Publish. Once you click Publish, I'll ask you whether you want to publish it in Excel or Google Sheets. Of course, we're going to use Excel. Click Publish, and it automatically converts all these formulas into numbers, right? So these are all numbers, and that reduces the pressure, computing pressure required. Now, don't make any changes, don't touch anything here, because when you submit it to me, I will click this and say unpublish, and it will give me back all these numbers. And let me just check here. In the old edition, when we publish, it would publish it for the entire workbook rather than for a worksheet. Let's see if they have fixed that. And so let's go here. Nope, they publish it for the entire workbook. So you want to do this after you finish something and you want to freeze it. You click this publish value. All right. So we finished simulation. Next, we're going to go to data table, and then finally we'll look at optimizer. So once you run a simulation and you got the statistics you need, you also need to be able to do a data table. So the data table works when you actually know that you have a decision variable. Now, sometimes simulation, you don't have a decision variable, but in this case, production is a decision variable. And we have asked that this decision variable, we want to look at what if it's 4,000, what if it's 5,000, what if it's 6,000? How does it affect total profit, right? So we want to run 5 different simulations, each one having a sample of 1,000, right? So remember, there's a difference between the number of simulations and the number of runs inside one simulation, right? That's like number of samples and sample size. So in this case, we are taking 5 different samples with different values of production: 4,000, 5,000, 6,000, 7,000, 8,000. And each one, we are having 1,000 runs, a sample size of 1,000. And then we will calculate all these right here. So we want to have the mean, standard deviation, your percentile, all this. But when we do it, we have to give the simulation number also in those PSI functions. We'll talk about how we're going to do the data table. And let's go to Excel. Before we go to Excel, when you do the data table, you have to go to Solver. You need to change the simulations to run to 5. It'll be 1. You've got to change it to 5. So it'll run 5 simulations. Of course, trials is 1,000, not 5,000, right? And now let's go to Excel, and I'll show you how to do this. All right, so you finished the simulation, you run the simulation, you've got all the statistics. How do you get to data table here? So I'm going to show you an easy way to do it. Go back to simulation and copy it. Make sure you copy the sheet, create a copy, right? You can rename this data table. You can delete all these statistics here, right? Go back to your basic model. And then in the production, you're going to use this function called PSI sim param, right? And then you open curly braces. You can put 4,000, 5,000, 6,000, 7,000, and 8,000, close curly braces. And this allows, basically you've told the computer that it needs to use in the simulation, the parameter for the simulation is, there are 5 different parameters, right? And you can go to options here. We need to run this 5 times, right? And whatever statistic you want to use, in this particular case, I'm going to just look at the number of simulations. I'm just going to copy this to make it easier. So here are 5 simulations. This is a decision variable. So I'm going to say mean. Let's go and do PSI mean. And then, of course, your mean is this, right? And then it'll ask you, so let's go ahead and put an F4 because this never changes. It'll ask you what your simulation number is. So you can put the simulation number here. So when you copy this down, the simulation number changes. If you don't do this, if you don't give you the right simulation number or change this to 5-year, that would be wrong. And a lot of you do that. So standard deviation, you can do PSI, ST, dev. Again, same, this F4, comma, whatever the simulation here, you can run through it, right? So you see how it's very simple now. Once you have to do the PSI sim param, and then you've got to change all these things that you've got, and you've got to put the simulation number for it, right? So let me show you the example here. Here I have given you mean, standard deviation, standard error, and confidence interval. So here are these. You'll notice that I've used the simulation number, right? And I'm just going to delete this, and we can run this. Let's run it 5 times. And so you'll see this, you'll have 5 different runs here, and the values will come here. You can see, well, if you produce 4,000 on average, you are going to make about $19,000 in profit. Here, you're 95% confident that it's somewhere in between these two. If you produce 5,000, then here's what you're going to produce: 6,000, 7,000, and 8,000. So it appears if you actually plot this, you'll see that the average profit is better for 5,000. 5,000 seems to be a good option. Now, it doesn't mean that this is the optimal level. We still haven't optimized it, but somewhere close to 5,000 seems to be. We have a gap of 4,000 to 5,000. There are so many numbers there. So we might need to do an optimization pattern, but it does appear that your profit increases and then it starts decreasing, right? And you can even look at the upper and lower level confidence intervals to see whether it's significantly different or not. Or you have mean and standard deviation. You can actually check to see whether these are significantly different. So here, the standard deviation is about 10, 8, 83, 139, 142. This is standard error for this sample means. So obviously they're significantly different here. They're very, very small. Remember, the standard deviation is sample standard deviation. So what you want is the mean, sample mean, and the standard error. All right. All right. So now we're going to the last part, which is how do we really optimize it? How do we find the best value of production so that your average is maximized? All right. That's the next and the last part of this lecture. So you've done optimization. You did optimization and forecasting. You've done optimization in linear programming. And so here we are going to look at optimization again in simulation. So here we have to figure out, and one of the biggest mistakes students make is they think this is your objective. You're not trying to optimize your forecasted variable. Remember, this is just one sample. This is not what you're trying to optimize. You can optimize the average. You could try to minimize the standard deviation. So it is the statistics that you're trying to optimize here. So average profit, you want to maximize your average profit. You've got to make sure this is back to a number, there's no function there, because remember, this is your decision variable, and when you run the optimizer, decision variables cannot have any function. All right, and then you've got to put some constraints here. This will be greater than 4,000, less than 5,000, and then you can run the optimizer. So let's go to Excel and do this, and I'm going to show you again what you should do for this. Okay, so you're here in this model. You have, started with the basic inputs, you did a deterministic model, then you built the stochastic model, ran a simulation, created a data table, and then you're asked to optimize it. A lot of times, students then go ahead and copy this data table, and they create a copy. Do not do that, because data table is so very different from the optimizer, right? So go back to your simulation, the original simulation, because this is an ideal format for you to run the optimizer on. So here you have this formula, you've got to delete this formula. Here the decision variable is a number, so it's perfect. So go back to this and then copy your actual simulation, click OK, and make a copy so it looks exactly like that, right? Then you can go here to your optimization, your objective, and in this particular class, because we don't have much time, we're going to focus on just the average of this particular value. Whatever your dependent variables, we're going to look at the average, and we're going to try to maximize the average. If it's total cost, we'll try to minimize this. So remember, you are not trying to maximize this total profit. Once you set there in optimizer, you are focusing on average profit. The statistic is what you're trying to maximize. Do not try to maximize the cell which has PSI output, right? Then your variable here, the variable you have is essentially C11, which is your decision variable. You might have more than one decision variable, and this is your decision variable. And then you are going to have constraints. First, I'm binding it that it's an integer. This is an integer, and it's greater than 4,000, less than 8,000. And then you're going to run this. Now, when you get to the optimizer, be very careful, because it's going to take a lot of time to run. Okay, so once you click on this, it's going to go on forever, right? So my suggestion to all of you is to set up the optimizer, and then you can, let me stop this. And if it's, you don't have to run it, you can try to run it, but you can click publish, and that'll publish the entire workbook and submit it, right? Don't open more than one simulation problem. Don't try to have 15 different simulation problems, because each workbook adds a load on your computer, okay? So with this, we finish this example. I know this is a long example, but if you know how to do this, we can focus on how to model the problem and less on how to do a data table and how to run an optimizer. Okay, so this is the basic model, and all of you should practice this. Make sure you understand how to use the random number generators, how to find statistics that you need, and it's a good problem to replicate and copy.